Hey everyone, welcome back. In this video, we are gonna solve a beautiful question. So without any further ado, let's hop in. So the question is on equilibrium point. Now let me just read out the question. Given an array A of n positive numbers, that is we have an array which contains only positive numbers, the task is to find the position where the equilibrium first occurs. Now what is this equilibrium? The equilibrium position in the array is a position such that sum of elements before it is equal to sum of elements after it. Now what does this line mean is, consider this array 1 4 3 6 4 3 1. Okay, these are its element. As it's told, it only contains positive numbers. Okay, so this 6 is actually the equilibrium position. And why is that? Because sum of all the numbers before 6 is equal to sum of all the numbers after 6. Because you can say 1 plus 4 plus 3 is actually 8, and 4 plus 3 plus 1 is also 8. Okay, so the 6, that is first, second, third and fourth. So the fourth position in this array is the equilibrium position. Why? Because sum of all the elements before it and sum of all the elements after it is equal. Okay, so you got the question. We have an array and we have to find the equilibrium position. Let's just see the input. The first line of the input contains integer t, denoting the number of test cases. Okay, simple. The t test cases follow. First line of each test case contains an integer n, denoting the size of array. Then the next line are n space separated values of the array A. Okay, this looks fairly simple. Output. For each test case, in new line, print the position at which the elements are at equilibrium. Okay, if no equilibrium point in the array exists, print -1. Now let me just show you a case where the equilibrium point may not exist. Let's just say 1 and 2. Okay. Now there is no possibility that the equilibrium point exists in this array. Why? Let's just take any element. Can 1 be a equilibrium point? It is not, because before it the sum of elements is 0. Okay, let's just say if no elements are present, the sum is 0. And if I take 2, no, indeed it is not possible. So if I can take any integer value. It's not like I've taken 1 2. That is to say, if the array size is 2, it is definitely not going to have an equilibrium point. It's not true for only this 2 size array. I can take something like this also, 4 9 5. You can say before this 9 the sum of elements is 4, and after this 5 sum of elements is after this 9 sum of elements is 5. So again there is no chance of equilibrium point. So what I'm saying is, there may be a possibility when equilibrium point may or may not exist. Okay, so there are some constraints given. Test cases are less than 100 and can be, so there are some constraints given. Okay, it's very simple. Let's just example input. The example input is 2. This represents number of test cases. Okay, fair enough. Then followed by 2, there will be on different lines there will be this n arrays will be given. Okay, so this 1 represents the size of the first array, and this is the first array value, that is 1. So the input is 5, so the next array size will be 5. Okay, so these are the 5 elements of the array, and output is 1, and it is fairly simple. Why? Because in the first array it was only one element, so it is fairly simple. This is edge case, right? If you have any one element, let's say I have 6 here, it is pretty simple that before 6 the sum is 0 and after 6 sum is 0. So if the array contains one element, the position 1 will be only the equilibrium point. Okay, that is very simple. For this 1 3 5 5 2, the position 3 is the answer. Okay, so if one more thing here, they are asking for the position, not the index. Okay, so if we see here the position 3, 1 3 and 5, 1 2 and 3. Okay, so this 5 is at the third position but index 2. Okay, so this 5 is the required position, because before 5 the sum is 4 and after 5 the sum is 4. So 5 is the equilibrium point. Okay, and its position is 3. Okay, there is an explanation here. So let me just take the input and then I'll make you understand the logic. Okay, so first things first, we need a t variable for the test case. Then I will take input in t. Okay, then we need to run a while loop exactly t number of times, and I have done this t minus minus because after every iteration t will be reduced, and eventually when t will be 0, this while loop will end. Okay, so let's just understand the logic. Now one logic is applying the brute force solution. Now what is the brute force solution then? The brute force solution is pretty simple. Just go through every element and check the sum before it and after it. If it's equal, then that position is our answer. So what is that is, just start from the first element. Okay, so if no element is present, then of course the sum is 0. Okay, you just need to check. Let's just say for the first element, check all the sum of elements before it and after it. For the second element, check the sum of elements before it and after it. For the third element, check the sum before it, after it. Eventually, you will land up in a position where sum of elements, if exist, sum of elements before it and after it are equal, and you can print that line. So it is simple code. You can just write it on your own. In the brute force solution, the time complexity will be order of n square. Okay, so we don't want that much time complexity. We actually want to solve a question in a faster way. Okay, so if we apply, what I'm saying is, if we apply brute force solution, the time complexity would be order of n square, and that we don't want. Okay, so the time complexity would be order of n square, but we don't want that. Okay, so the method that we are going to apply here is fairly simple. What we will do is, we are going to actually apply the same logic, but instead of finding the sum of elements before a particular element using the for loops, because in the brute force solution we need to actually apply the for loops for all the elements before it, for all the elements after it, we are going to run this in a single loop. It will be more clear when I code it. Let me just first take the input of the size. Let me just name it appropriately, size, and the next thing we want is an array. Okay, let me just first take the input of this size. Okay, so this is size. Then we'll have an array. Okay, so the array will be of size. Okay, makes sense. Let me just take the input of the array, int I equals to 0, I is smaller than size, I plus plus. Okay, so we need to take input of every element, so it will be just fairly simple. That's not much of I'm doing. I'm just taking the input of all the elements of array. Now one more thing I will do. What I will do is, I will actually find the sum of all the elements in the array. And why I'm doing this, you'll understand in just a bit. Okay, so just bear with me. Let me just initialize another variable here only, beside size, and let's name it total. Okay, let's name it total, and I'll initialize total to 0 if I can hit correctly. Okay, so I'm taking another variable which will hold the sum of all the elements. So I'll just add as soon as I take the input every time. So I'll just add it to total. So eventually, after all the inputs, value of total will be sum of all the elements of the array. Okay, so the next thing we have to do is, we have to actually print the equilibrium point. So for that, finding the equilibrium point, I'll actually make a function. So let me just write out. So I'll just pass it into this function equilibrium, which actually takes our array, then its size, of course, and the total. You'll understand just a bit why I'm doing this. Let me just write out this function equilibrium. Let me just write here end line. Okay, so that every output is printed up. There is a line after the output. So let me just define this function. Okay, so the function will actually return an integer, right? So it will be a integer function. Okay, int equilibrium. Okay, so the first input will be an array, so that's where I get star. Then the next input is the size, then the last input will be the total. Okay, simple. Now what's the logic here is, what are we gonna do? We are actually instead of using two for loops, we are only going to use one for loop. And what, because if we know that if we use the brute force solution, we at every index we need to use two for loops. Okay, so that's not a viable solution. So instead of that, what I'll do, I'll go to every index, and for that index I'll check the left sum, that is all sum of all the elements before it, and I'll compare it with the right sum, that is sum of elements after, using variables. Okay, so let me repeat it again. I'll go to every element, that is a element at every index, and I will actually compare the I'll actually compare sum of all the elements before it and sum of all the elements after it. So what I mean is, let me just write the loop int j equals to 0, j smaller than size, because I want to go through every element, j plus plus. Now to do that, I'll need to maintain another variable, and that variable will be left sum. Okay, and the left sum starts from 0. Why? Because at the first index the left sum will be 0. For example, when I start from this 1 here in this array, initially the left sum will be 0. Okay, now in consecutive iterations, I'll actually increment this value. It will be clear in just a bit. Okay, I'll start the left sum with a 0, that is sum of all the elements before is 0. Okay, makes sense. Now, what will be the right sum for the first element? Okay, let's say before the starting point of this loop, what will be the sum of all the elements after the first element? It will be simply total minus array of j, right? So if it is the first element, the sum of all the elements after it will be simply total minus, if it's the first a of j will be 0, right? So this example 1 4 3 6 4 1, at the first position the left sum will be 0 because there are no elements before 1. Okay, now the right sum, we know that in total we are actually holding the sum of all the elements. Okay, so why don't I subtract this one only? So that's what I did. Okay, so let me just hold it into another, let me just hold it into total only. Why don't, it's fair. So what it does is, at every iteration total actually contains the right sum. What I mean is, we write it above, total holds the right sum. What is right sum? That is sum of all the elements after that particular index. For the first element, it will be simply sum of all the elements after the first element. Okay, makes sense? Okay, now what will we do? We'll simply compare this total, because we know total is the right sum. We'll simply compare it with the left sum. Okay, this is the test case for this will actually hold true when there are one elements. Why? Let's just say this 6 here. Okay, let me write it here only. What if our array contains only 6? We know that left sum is 0. Okay, because for the first element the left sum will be 0, and this total, it will be total minus, total is 6, right? Because we are finding here total. The total is 6. Total minus a of j. A of j will be 0 for the first element. The total will be 0. So the first element, this total equals to left sum will be actually equal, right? So what I'll do, I'll just simply return index, or better say I'm writing here j, right? So I'll write j plus 1. And why I write j plus 1? Because we actually want the position, not the index. Okay, and this is not true. Simply increment the left sum. And how will I increment the left sum? It is fairly simple. For the next iteration, we are actually after one iteration we'll actually add that particular element to the left sum. Okay, so I'll write something like this, array of I. Okay, so if this is not true, simply increment the left sum, because when the next time we are actually finding it, the left sum will be actually for the second element. That what I'm saying is, for the second element the left sum will be actually the first element, right? And for the third element it will be actually first element plus second element. Make sense? Okay, now what if this for loop never returns? There may be a chance that total never equals to left sum. For this example, this 495, this total will never be equal to left sum, even if we keep on decrementing it. So for that, the last case is simply return -1. Okay, this will be case with this cases, all the arrays of size 2. For the sizes of array 2, it will always return -1, because these loops won't run. You can trace out the solution if you want. So I guess that's it then. Let me just compile and test it. Yeah, it actually compiles fine. Let me just submit it and see if it passed all the test cases. Okay, so it actually executed completely fine. So this problem is solved then. Okay, so let me just quickly go through the logic. What we did here is, we've actually first take the required inputs here, and we actually found out the sum of all the elements in the array. Okay, then what we did is, we go through every index and compared the left sum with the right sum. What is left sum? Sum of all the elements before that index and sum of all the elements after that index. And we initialize left sum to 0, because for the first element the left sum will be 0, because there are no elements before it. Okay, and for the first element, what will be the right sum? It will be simply the sum of all elements we counted minus that particular index. And we know that after every iteration, this total will be updated, so that we get the respective right sum. Okay, makes sense? Okay, then thank you for watching.